Hey guys, welcome to the last session of data science and machine learning. So, thank you very much for uh, uh, being faithful from the start to this time. So, I'm very grateful for you guys because you have supported this initiative, you have supported this training. All I want to do is to make sure that I get you up and learning and you get to know these technologies. They are not intimidating, as you can see. They are very easy to understand and to get hold of them. So we have learned amazing things that we can do with the data science, data pre-processing, how to do fast computations with NumPy, how to do visualization with different libraries that are very professional that you can use, and they are used every day in the world in big companies. So I think those ideas, those knowledge, that knowledge that you have gained, you can use it to start your own project, and I'll be happy to see what you guys are coming up with. Now today I'm finishing with machine learning. So as already people, if they hear about machine learning, they are very much intimidated. They say this is very complicated, we can't understand it and whatnot. Trust me, this is the easiest of them all. And I'm telling you, you'll be surprised on how we do these things. Now there are a little bit of analytics that you have to do with machine learning depending on the model set and the data set and whatnot. So those areas I will not teach or focus in this course because those are a little bit professional, but they're easy to understand. But in this course, I just want to focus on the simplest way you can actually create your own machine learning model, and you can become a machine learning engineer after this video. So let's get started. But before we go to coding, I just want to show you or to define the terminologies that we are going to learn today. And the first one is, what is machine learning? So it's a way of training your computers to do something without being explicitly programmed. So you just teach your machine, if you see this, it's something. If you see this, is something, and that's all you do. And that's why machine learning is very easy to implement, because once you have trained the model, you are done. The system will do the rest for you. So let's take a look on the types of machine learning. I have a picture here. This type is called supervised learning, and this one is the one that we are going to focus much on and learn in this video, because I'll only teach supervised learning, but however on other courses, on private courses, I'm going to focus and teach much better on unsupervised learning, transfer learning, and reinforcement learning. So let's take a look at the example of what is supervised learning. So in supervised learning, you need to have data set, already existing data set. Take that in mind. Now this data set is labeled data. It means if it is talking about the sex of the person, the age of the person, we do have the values. So it's already annotated. So if we see here on this picture right here, you can see we have labeled data and labels. Now labels are like output. If we compute, these are the features of this data. What makes a rectangle? A rectangle, it needs to have 4 corners. That means the rectangle. What makes a circle? It needs to be rounded. That's all. Now you put that into a machine. Now your machine can be your computer or your phone. Then you run a model. Now this model, if you train this model, you are going to put test data. Now test data are just labeled data. There is no output. Once you put in the test data here, you are going to receive the output as so, the predictions. So that means this labeled data, itoka data yote wangwebeza by internet, but this test data can be the real data if you have deployed the machine learning. model, and it will be able to predict what you are doing. Now let's take a look example on what is unsupervised learning. Let me decrease this view. Unsupervised learning is like it clusters. It does clustering and association. Now if you see here unlabeled data, we just put in a lot of data. We just now if you put into that model, what happens is that this machine learning model is going to be clustering kapena kusanja kapena kulongeza zinthuzi depending on the features that are similar to each other. So for example, 4 corners zipanga cluster, like circles zabanga cluster, hexagons zabanga cluster. So you will be able to do this, and this is very important when you are doing data mining. This is what Facebook does to our data. My message everything they cluster that so that they can give us adverts depending on what we chat with our friends. So don't think you are having your privacy with these digital solutions out there. They are taking your information. Now let's get back to our machine learning lesson. So in this lesson, we are going to introduce you to a new library called sklearn, and I believe that at the beginning of this course, I told you that you should install this library in your system. So let's import necessary libraries that we are looking forward to have in this course. Now let's import our favorite library, NumPy as np, and let's import pandas as pd. Let's now import from sklearn, that is the library that I told you about. From sklearn dot, there's a method called pre-processing. Now in here, let's import label encoder. So what does this label encoder do? We'll see that later on. Now let's import sklearn dot model selection underscore selection, import train underscore taste underscore split. Don't worry about this thing. I'll make sure that I will teach you what they mean. So let us also import another one called, now this is the model that we are learning from supervised learning. It's called linear regression. In supervised learning, we have 2 groups of supervised learning, regression and classification. So in classification, it does with categorical data, but in regression, it does with continuous data, and we'll see what happens right here. Now we need to go to linear, that is from linear regression family. Now import in here linear regression. And so let's learn this. Yeah, we are good to go. Now let's import our dataset. I have downloaded dataset from Cargo, or you can find it anywhere in online. Find any dataset which is in CSV format. Now this dataset is in my Google Drive. If I go here and I just need to press these buttons and copy path right here, and go and paste the path in here. So you just need to do Control V and you are done. Let's run this. Boom, we are done. Let's see the head of our data. Now this is the data that we are actually using. We have insurance.csv, and it's talking about insurance yomwe ungakhale nayo depending on some other features. So for example, age, sex, BMI. So this has to do with biomedical, some sort of I think some sort of like is it what measure of body fat or something like that. I think so. It's body mass index or something. I don't know. I just downloaded this data online. But those who are in the biomedical field, I think this is your time to shine. Now, look at the data. You see that we can't, and this is a confession, we cannot train our machine learning model using these strings because these are objects. So if we go here and say df.info and learn this, you see this 6, it's an object. A machine cannot know what you're talking about. These are strings. A machine works with numbers. Your PC crunch numbers, so we can't actually work around with this. We need to change this to numbers. So how do we do that? Remember this guy, the label encoder. It's able to change. It's able to change the strings into labels in numerical features. So, for example, if I want to learn that label encoder, I need to instantiate the object. So I'll just say label. Now this is my variable that I've chosen, label encoder. You can choose any word that you want. Now label encoder, let me instantiate the object. So I'll just type label encoder. Then after that, let me learn this. So what I did here, it means everything, every function in this object. So this is like a class in a certain file. Anything, any function that is in this class, I shall access it using this variable. Now let's actually learn this. So I can just say df and select the 6. And inside that 6, I want to transform. So I'll just write label underscore encoder. Now there is a function called fit underscore transform. Now that will transform the data. It will actually automatically say, okay, data here, I think I should transform to 0, 1 or 0, 1, 2, 3, depending on how different they are. So let me put here 6 so that we should transform that and save it into this column. Let me learn this. Now, before we see the data, okay, let me just show you the data, what happened. Let's learn this. You see now 6 is made into 0, 1. And if we go here, 0, it means female, 1, it means male. So keep that in mind. Now, let's also change smokers. And in here, let me put smoker. The same thing right here, label underscore encoder dot fit underscore transform, and let's put in here df smoker. I think yeah, it has landed. I thought I have made a spelling error, but I think we are good to go. Let's run this and check. Oh, no, not kdf. I know this is an error. It should be df. Now let's learn this. You see smoker is right here. We have yes equal to 1 and the no equal to 0. That's how powerful autoencoders are. Let's finish with this region right here. We have northwest and southwest. So you need to have df and region. And let's say label underscore encoder dot fit transform, and in here let's put df and let's put region. Learn this and let's see. what we are dealing with. You see now we have 3, 2, 1. So we have southwest, southeast, northwest, west here. You have southwest. So it has actually changed from 0 to 1. And yeah, you can play around with that one and keep the labels if you want to. Now, let's see what we can do. So now we can actually visualize our data and see the relationship that we want. So for example, if I say import Cborn as SNS, and here let's just import matplotlib dot pyplot as PRT, and in here let me just put matplotlib inline. Let's learn this. We just need to visualize our data, so I can just learn sns.pairplot. If you can remember pairplot, you are good to go. And in this pairplot, let me just put df so that I can just see what's going on with my data. And let's see what will happen. So depending on the data, it's going to be slow or fast. I think we are good to go. Let's see. Yeah, now you can visualize what's happening in this data, see the relationship of the dataset that you have. Now, if I just see like this and I say, okay, what is the edge? So you can see the charges. When the edge is increasing, the charges are also increasing. So yeah, that's what we are doing with data visualization. And you can also do heat maps. So remember, we do sns.heatmap. And by the way, heat maps actually accept correlated data or pivot tables. So you need to put df.core here and learn this. Let's put annotation equal to true. So equal to true. Let's learn this and see the heat map. And we are good to go. So you see the relationship between these ones, and you can appreciate what's happening right there. So you can see my relationship between BME and age. We have 0.1, so that means there isn't any much relation. But let's take a look at this. This is interesting. There's a smoker and charges, so there is at least direct proportion. Means omakusuta kwambiri ndo mamakhaso ndi insurance charges yoyulu. Yeah, that's American. Now let's see our distribute so that we can see what the overall dataset is talking about and see the normalized relationship. So we can just say df. Let's put the charges and see kodi anthu ma charges ali munthu kwambiri. Let's put here KDE is equal to true right here so that we can see our kernel density estimation. Let's run this. Now you can see my charges ambiri are between here, but after that we are seeing the charges normalizing and there is a bump here. Why is 40,000 right here and ambiri? That's the question that you need to answer if you are doing data analytics. Maybe my customers but you see this charge right here, maybe anthu amene wandachikulire, you never know. And right here anthu ambiri amakhala healthy, that's why they don't go for insurance, but ambiri ukuko ndi ana, so you can insure a kid. Yeah, that's the analytics, what it's all about. Now df.column here, let's check our columns and learn this. You see this is our column. The reason why I've done here so that we can just copy these columns and paste them. Now let's put a variable here called the training underscore data, that we need to split this data set. Label data and labels. Now we need to split them. Now to do so, I need to assign the data frame to training data. Once I do this, I can use this to like split them. Now, by convention, test data umayenera training data umayenera kuti uyike mu variable yochedwa kind also training data, but features or label data, you need to put them in a variable called x, capital X. So if I say here x is equal to, and just like training data underscore data, and in here, because we want to select multiple things, we just, okay, let me just select this, press Ctrl C and Ctrl V, then Y. Our labels should be in small letter y, so I can just say training underscore data. Then let me just copy the charges here, and we are done. You can use dot notation, but I think this one is very intuitive. So we have a certain method called a train test split. Here, if we go upwards here, we had from model selection, we imported the train test split. Now, this train test split actually helps us to split the data that we're working into training data and also into testing data. We need to test our model if it is accurate. So to do so, what we need to do is to leverage that data set, we need to do tuple unpacking. Those actually who knew about tuple unpacking when we are doing visualization in Matplotlib, they can understand what I'm talking about better. But don't worry, I'll teach you how it's done. So we need to write x train. You can choose any variable that you want, but this one is a conversion. It's actually needed. Then we can just say x test. What do we mean by this? It means we will need to split our data into training data at a certain percentage and testing data. My label data, ndima labels. Now we need also y train and y underscore test. Then let's put here the train underscore test underscore split. Here it's a method. Then inside we need to put the x data frame and the y data frame, then the test size. The test size here. Now our test size is going to be 0. All right, our test data frame is going to be 0.3 because that is said 30%. But what do we mean by this? We mean that if panga split data and 30% ibita ku test data and 70% ibita ku training data. That's what it's saying. So depending on your data set, you can do this. But let me put here 20% so that test size ikalijani 20%, because we need to train with a lot of data, because Zinza machine learning, it requires a vast amount of data. But because we're working with here an example, we just need to use 20%. Now let me add a random state so that we should be in the same area. So random state we can just add 42. So that, what does it mean by random state? It means ma values omwe muda apeze ababa, the splitness ibanga split mofanana ndineyo. So mukamapanga lani algorithm anu results akakhala kufanana ndine. So it's good you should use random state ya 42. That's what that variable is trying to mean, so that results anu akhala kufanana ndi aineyo. Yeah, it's the same as random seed. Now let's run this, and boom, we are good to go. Let's check the x underscore train and dot shape and see the shape. Yeah, we have 6 columns right here, and it means we have 1070 data points. Now let's try y train here. Dot. It's good to do shape because you may have my data points and it cannot work. It can't work. That's why there is data preprocessing. Tinapuzira pandas, what we are doing with pandas. So it's very important. And I think we are good to go by this. These data sets are widely used and they are preprocessed very well. Now let's go to our machine learning model. Now, if I go upwards here, you see that I had this model called regression. That's what we are doing, linear regression. Now, linear regression model, in order to access that, you need to put a variable and instantiate that model. So I just need to put here linear regression or linear reg underscore model, and I'll put here linear regression, and let me learn this, and boom, we have added that model inside our system. Then this is where you are going to learn your machine learning model. Now let me show you how easy it is to do that, and don't be intimidated by anyone. You can just say linear underscore regression underscore model dot fit. Fit is the same as training or something. Now let me just put here x underscore train right here and y underscore train. Let's learn this, and this is your first machine learning model. It's as simple as this. Learn this, and we are done. You have your first machine learning model. Have you seen it? It's 1 second. How cool is that? I think by this now, call yourself a machine learning engineer. Don't be intimidated by the internet or anything. What you have done here so far, you're good to go. Yeah, you can apply this in anything. Now let's go to our predictions. How can we do predictions? Now remember, we do have the test data. Yeah, we need to test our model if it is actually good. Now let's do predictions. A variable. I just put a variable. You can put anything you want. You can put it in GGR. But this object that we have instantiated, don't put it whatever you want. And let's put linear reg dot. We have another method called predict. Now in this method, let's just add x underscore test. Learn this, and it's running in the background. Boom, 0 seconds. We have already made our predictions. Now, to check our predictions if they are accurate, we can just say prt dot scatter and y, and you can just say underscore here and test, because test, remember, x test and y test. X test ndima label data. We have made our predictions using this model. It means we don't know the results. Y test, this is a new data set. Then what is the actual output in the predicted output? Now let's go to do scatters, scatter with predictions, and learn this. And wow, let's see what's going on here. And if you see these lines, just know our model is not as accurate as we want it to be. So it means we have fewer data points, or this is not a perfect model for us. So I wanted to show you this, if it is not in a straight line, and you have seen because this is a linear model, it has to be on a straight line. it means kuyambirira yapanga predict bwinobwino, but as it goes upwards, it's actually flying around anywhere. So there are other ways we can actually see the score. So these methods can be obtained from method from sklearn. So sklearn, just need to put sklearn here and import matrix. So from this, if we run this, let's just learn the predictions. So I can just say print right now. Let's learn the prediction. So we can let's learn the accuracy scores. There are some other errors that we can actually predict. We have the absolute mean absolute error and mean squared error, and mean squared root mean squared errors. So these things actually, they help us understand what is going on with our data, and the lesser we get them, the more accurate is our data set. So let me just learn the root mean squared error. So as a machine learning engineer, make sure you strive to get this output very small. So in order to learn that, let me just learn to, because it's root mean squared error, so we just need to have the square root sqrt of the mean squared error. So you can just say matrix dot mean underscore squared underscore error, and let's put in here the y test and predictions. Learn this. Now you see the root mean squared error is 5798. So make sure that this value has been reduced as small as possible. How can you do this? Make sure you have enough data set. You have maybe 5,000, 10,000, even 20,000 of data points, so that your machine learning should be actually good. Now let's predict, because we can't actually learn about machine learning without predicting with our own values. Yeah. So in order to do that, let's have a parameter here called new data is equal to np.array, because these values actually accepts arrays, dimension arrays. And so there are lots of ways you can actually do this, but I think this one is very intuitive. You can know what you're doing. Now, remember, the first part is the age. The second part is, I think, sex. So means one is a female, is male, and I think one is female. I don't know. Then the BMI number, let's just put 30.15. Then let's put here number of children 5, and are you a smoker or not? 0. I'm not. Then let's put I'm living, I don't know, southwest or northwest, these values. You can map them to see what you are doing. Now we need to reshape our array to my dimension, so we just need to reshape. So we just need to put here 1 and -1. So we have reshaped it to be a single row and multiple columns array. Let's learn this. Yeah, we are good to go. Now let's predict. I'll put the prediction inside a variable called result. Let's put linear underscore here leg underscore model, and let's put predict inside that predict, let's put new data. Let's run this. Boom, we are good to go. Now let's print the output. I can just say here the insurance charge is print number 1. Now I can put US dollars since this is from US dollar. Then let me add an int here so that I should explicitly convert the result to integers. So let me just put here the result, and since the output it gives also an array, these machine learning models actually give you arrays, so you have to map them to get the value. But just because we are predicting one thing only, that means it's only one thing in our array. So let's just print this and see the result. Yeah. Now we are seeing that the value of a person with 45 years of age, that is the value. Now, have you seen this number? Let's actually check to our pair plot upwards. We have 11,300. Let's check if this number, the age, let me just say here, age 45,000 and have 11,000, because 45,000, I think it's light here. Yeah, if we go upwards here, you can see, yeah, and there are other features as well you need to take into consideration. And the BM value, I don't know, but 30 something, so it's 30 something. You can actually see the age or something. The charges, you have 11,000 something here, the BM value, the charges value, and whatnot. I don't know, you can actually figure that out. We have children as well, so you check the children, so it predicts for us. We don't need to check these things manually, but you can appreciate that it has actually predicted our value and whatnot. So if you are into Python programming, these things you can put them into a function and learn that function and deploy it into the server. But anyway, thank you very much, and I appreciate your patience for being in this course. You have been with me, and see you in the next adventure where we learn more about machine learning. Thank you very much.